Right. Example 5B, the population of various cities in thousands, the average walking speed feet per second live in the city. Create a scatter plot for the data. Based on the scatter plot, what type of function would be a good choice? So my X is my population, my Y is walking speed. I've got to go up to almost 400. So I'm going to go up by 50s. Okay, so I've got to go up by 400s. And then my Y walking speed, so this goes up to 2. So I need to go basically by 0.5 or 0.25s. And 0.5, I'm gonna label every other one. 0.25, 0.5, 0.751. So that's, I'm having to kind of, then I'm gonna go plot these. So 5.5, that's really low. And then 0.6 right there. 14, a little bit further, and 1.0. 71 and 1.6. So that would be right there. 138, so that's going to be right here, and 1.9. And then I didn't go past, forgot that, just one at 2.2, 342, and 2.2. So let's look at that. We're going to look at the curves here, what we got. And so this is an exponential. There's an exponential growth here where it curves up, open. This is an exponential decay. This is what we call a logarithmic one. Okay. This is another example of a logarithmic one. All right. And then they're linear and linear. Okay. So what are you seeing here? You see a curve. It's kind of like concave down. So I would guess the logarithmic one would be best here on this one. So I would choose logarithmic. Now you can check this. Okay. And I'll show you real quickly. I'm just going off the shape. You see that's a curve. There's a distinct curve and it's kind of curved concave down. Like it's kind of curved open downward, where these are like open upward. You could type these in your calculator. First off, go to mode and stat diagnostics, and they're turned on. You want these to be on. Okay. So to get out of here, and then this isn't going to be perfect, but if I go to stat enter, clear all this out. Clear. I'm sorry, I went too fast there. If you got values in there, go to the top, press clear, and then press down. Press clear, press down. By the way, we got the answer here. You don't have to go like that. We know what the answer is going to be or what it should be. I'm just trying to give you more something you could do here to check it. Okay. Then you could go to stat. Now let's go through the options here. Stack calc. You've got linreg, which is the linear one. I'm going to select that one. L1, L2, second one. And what I want to look at is the R value. The R is 0.865. So that's, by the way, above 0.8 is strong. So that's strong. So 0.865 is pretty good. I want the highest R value. So 0.865 is my linear one. Should be writing this down, but I'm not. Now, exponentials, EXP-reg. That's EXP-reg. Skipped LN-reg, L1, L2. What's the value here? 0.78. So exponential is weaker than linear. With linear, it's 0.84, exponential is 0.78. So now let's go to LN-reg for the logarithmic one. LN-reg, this one better be good. You see it's 0.993. It's that the closer it is to 1 or negative 1, if it's negative, the stronger it is. So this one's, the R value is 0.99. That's really strong. And you could tell that. So it is logarithmic. You could tell by just looking, but that proves it to you using the